All right, hello year 11. So today I had to be somewhere else, so you have a little exercise to do together hopefully, and I would like you to leave the work that you do today during the lesson behind you when you go, so I can see it this afternoon. And so you will all have individual versions of the work that you're gonna discuss together. So hopefully that makes sense. You all work individually on your own piece of paper, but you're gonna do the thinking and the talking, and you can help each other while you do it if anybody gets stuck. So this is not a test, by the way. It won't be evaluated in a serious way, so don't worry. But I will expect you to complete it during the lesson and to work hard at trying to do it properly. Should hopefully be useful revision. Okay, so let's get on with it. First thing I would like you to think about and then explain in words as briefly and as clearly as you can is why this equation, velocity is equal to distance multiplied by time, why that equation is complete rubbish. Okay, so you should know that the right equation for velocity is not like that, and I want you to try to explain in words why this equation does not work, why that would give you a silly answer. And for that the best thing, what I recommend is that you come up with examples. Just one example is sufficient, or perhaps even better two, choosing a different letter each time, for what this answer would come out to be if you gave it a certain situation. So I'll give you an example with a different equation. Let me see. Well, I'll give you a bit of a hint to do with these ones. So keep the meaning of what the letters normally mean in the equation. So by that I mean, for example, the letter T in the equation normally takes time. Normally it means time taken for traveling, right? Distance d, right? And actually normally we use an S here for this placement, but anyway, it doesn't matter. So that's the normal meaning of the letter T, and the normal meaning of the letter D is the distance traveled, obviously, and the normal meaning of the V is just the velocity at which you're traveling. So keeping those meanings for the letter T and the D, then I would like you to think about what this would imply in terms of the velocity. So if you came up with an example for an amount of time and a certain distance, then what that implies about the velocity. Hopefully that makes sense. I think there's a couple of people there in the lesson right now that have heard me talk about this kind of idea before, where you try to understand not only why an equation is the way it is, but also why it's not any other way. So for example, the equation is normally d over t. So if I look at this equation makes sense because I know that if I have a distance of 2,000 meters and I cover it in a time of 2,000 seconds, I know that my velocity is going to be 1 meter every second. And it makes sense because if I go at 1 meter per second for 2,000 seconds, I'm going to travel 2,000 meters. So that's pretty sensible, and that's why the equation looks like that, because it's quite sensible. But this equation here would reveal different results if you just follow the thread and you talk about it between yourselves to see what kind of conclusions that would lead you to. Then please write an example, each of you, which would make it obvious that this equation is wrong or is somehow absurd. So for example, if your little brother or sister was asking you, why this equation is not right after they've tried to use it, then you could use this argument that you're going to explain to tell them why it doesn't make sense that that it is like that, and therefore how it would have to be in a different way. Okay, so that's the first exercise. Stop the video right now and take 10 minutes to do that. There should be plenty of time to do it properly. Alright, pause it and continue in a sec. Okay, the second idea that I would like you to think about is the formula that relates density with volume, and don't know why I'm going to use a different kind of and there, and what's the other one? So density, volume, and mass. Okay, so they have a pretty intuitive formula that sort of makes sense when you look at it, and I would like you to, in a similar way to the one before, to try to explain why the formula to use shouldn't be this one. So what's the unit for rho? That weird P, okay? A lot of people draw it just like this, but it's important that it doesn't look like a P, okay? It's supposed to look like P is for pressure, so it's either like that or like that, okay? This one's probably the most common. So what's the rubbish equation this time? Well, it's gonna be this one. I nearly wrote the right one. Okay, so that's our equation, and the aim of the game this time is to now explain why this guy, why is this one utter gibberish or gibberish. I'm not very sure. I think it's gibberish, correct pronunciation. And so why is it not like this? What would this imply, and what would this translate into words, and why would this not make very much sense in terms of our normal understanding of the word density? All right, and I'll just give you a reminder that if you don't know the correct equation for this, then go running to your textbooks or to your own notes and look it up. Okay, but the idea of density is that you have a certain volume, like this box, and the idea of density is that you have a trillion billion, something's very, very dense, is that you have loads and loads and loads of particles of matter inside of that volume, right? That's a high density. That would have a much higher density than if you had a, oh dear, my cubes just suffered a severe, okay, so a cube, something like that. And if we compare that situation I just drew with very high density with another one where you have this, then this as a material is much more dense than that one there, okay? And this cube is a sort of a fictional cube, so the material is really the orange thing. It's just the cube is trying to show you that in the same volume as this one has much less matter than that one. So this is a denser situation, there's much less density here. In other words, this same volume would have a larger mass than this one, which just has a little mass, even for the same volume, because it's less dense. So go and look for the right formula if you can find it, or one of you probably remember, and talk between you about why this is utter rubbish, and explain it please in your own words. Okay, so you're allowed to work in group to discuss it and see what's happening, but try to come up with an explanation in terms of your own example, your own numbers, and things like that on your own, if possible. Okay, talk as much as you need with each other. Except you've got about 10 minutes for 10 minutes for that one also. Okay, so pause that now and we'll go on to the next one next. And for our third idea, I wanted to talk about, I wanted you to think about the idea of relationships between force and what's happening there? Pressure and area. Okay, those three guys, they're related by an equation, and I'll give you a clue about the equation. It's not the one that I'm going to give you. P is equal to F times A. Why not a true thing? Okay, why is not a true thing? Why is this relationship not true? And again, think about examples and come up with a way of proving that this is absurd and it wouldn't make very much sense. The idea of pressure, remember that it has to do with how much force is applied on a certain thing. So for example, if I have a ice skating shoe, then the idea was that by having a very thin thing on the ice, there is a very high pressure, and that can melt the ice a little bit because of the pressure, and then I can slide on a little bit of layer of liquid water all throughout, and then that works really well. Whilst if I was on fluffy snow, I wanted, instead of having a lot of pressure on a very sharp object, I want to have these rackets under my feet, so I can then walk around without sinking in, because then I have the opposite of that, and have a low pressure. So that was the idea of pressure. If you can't remember the proper formula, go and look it up, but this should be kind of clues, and let me know why this guy here is not the right one. Now I'm gonna ask you something a little bit more challenging, well, just in terms of time, but let's see if you can do this before the end of the lesson. Go to where we were before. So now these three formulas, you should know them quite well, but go to here and do the same thing that you did before, okay, to show why sorry, so I should have said, so pause the video again until you do this, and that should be another 5 minutes. Try to do it in less than 10, and now that you know what the process is like, it should be quicker than the other two. And then once you've done that, then scroll to the top and then do this, and this will be your exercise number 4. Your exercise number 4 here will be to deform this equation in yet another way. Okay, so this is the right one, and how are we going to deform this guy in another one that we haven't deformed it yet? So instead of v is equal to dt, let's see, we could have t is equal to vd. Okay, so t is equal to vd. Try to explain why that is rubbish. Okay, that'll be your 4th exercise. Your 5th one is going to be related to this, deformed in a different way. So let's see how we can deform this. Well, we can say that rho is equal to mv. There's another deformation that we should be able to see why that's silly. And finally, the number 6 exercise will be a variation on this one here, and that will be pressure is equal to area divided by force. So that's your other one. So I'm going to write them all on the same page, so you don't have to be flipping all of these now for the last 3. So you've done the previous 3 hopefully. So 4, 5 and 6 are then here, so I'll put them all on the same frame, so you don't have to scroll up and down. So what was it? P is equal to A over F. P is equal to A over F. Okay, and that is a P. This isn't. That's a rho, and that's a P. So these are your 3 for the last exercises. And let's see by the end of the lesson who can come up with these 3. These 3 are going to be a little bit more of a race, because it'll be tricky to finish. Do those more on your own. But the first 3 you were supposed to do in a group, because it was the beginning of the exercise. Hopefully you could help each other out. Why is all of this important? You might be thinking, sir, you're gonna drive us crazy and you're gonna make us forget all the formula, and it's not like that. It really isn't, because the moment you understand why all of these things are absurd, then you'll develop a much closer relationship with both the concept of what's going on and the formula, and you'll be much more likely to remember it. We're going to do plenty of practice between now and the exam, so you'll get lots of time to practice the proper formulas. Alright, so hopefully that helps. These are the last 3, and good luck, and I'll see what you've done when I get back from the being out of the school. Alright, take care.